Let's talk about scientific notation. So, scientific notation is something that's obviously used a lot in science, and the use of scientific notation is that you can take numbers that are very, very big or very, very small and write them using fewer numbers, let's say. So, we're going to take two numbers that are not extremely big or extremely small, but hopefully will illustrate how you can use them to take numbers that might be even bigger or even smaller than these and condense them. So the numbers we're going to use here are 201 million. That's going to be our really big number. And then our really small number is 0.000051, which if you count the places, we go 10 tenths, hundredths, thousandths, ten thousandths, hundred thousandths, millionths. If you count the places over, this is 51 millionths. Um, is our teeny tiny number that we're going to convert into scientific notation. So one of the things you need to know about scientific notation is scientific notation always has one thing in it. It always has something, some number, times 10 to a power. Okay, it's always some number times 10 to a power. Now, within that, there are a few rules for scientific notation. One of the rules is that the number, the sum number, is between 1 and 10. Now, I need to be specific there. The number actually has to be less than 10. So I should say that the number is at least 1, but less than 10. So the number could be 9.99999, but wouldn't actually be 10. Though the way that you can tell if a number is written in scientific notation is that this number is going to be a single digit followed by a decimal. So, for example, if I had something like, let's say 3.2, that's good. That's scientific notation. But if I had something like 32.4, that is not okay. This is not scientific notation. So it's going to be a single digit and then a decimal point. That's what the sum number looks like. So it's a number between 1 and 10, a single digit followed by a decimal point. If it's a two-digit number, or let me give you another example, if it was like 0.32, that is also not scientific notation because it's not between 1 and 10. So there's another example, not scientific notation. Okay, so it's going to be a number between 1 and 10 multiplied by 10 to a power. So what's the power? Well, the power is either going to be a positive or a negative number. So if it's a real big number, the power is positive. Power is positive for big numbers. And when I say big numbers, I mean numbers that are bigger than 10. That's what we mean by big, bigger than 10. Really, I should say bigger than 1. You can use scientific notation to write the number 1, I suppose. You know what? No, I'm gonna say bigger than 10. I'll get to the 1 in a second. The power is negative for small numbers. And that'd be numbers that are like smaller than 1. And the reason I want a distinction is this is like our special case. The power is 0 for 1, or single digits, I guess. You'd rarely use scientific notation for that, but I suppose you could. If you wanted to be a weirdo, you could use it for single digits. Okay, so positive for big numbers, negative for small numbers. Oh, I just realized I'm writing like a caveman. Power is positive for big numbers. Positive for big numbers, negative for small numbers, and 0 if you're going to do it for a single digit, but you really don't use scientific notation for a single digit unless you're just trying to be funny. So let's go back to our two numbers. So we've got a big number, 201 million, and a small number, 51 millionths. So obviously the one on the left is going to be our times 10 to a positive power. Okay, so this is going to be something times 10 to a positive power. And we already said the something, the sum number, has to be a single digit followed by a decimal. Okay, so here's what we do. We look at our first set of numbers here, the first numbers in 201 million, um, our set of numbers that are before the big long string of zeros. See, we've got this big long string of zeros here at the end. I want to look at all the numbers in front of that big long string of zeros. And the number in front of that big long string of zeros are 201. So 201 is going to be the number in front of the multiplied by 10. It'll be 201. And since the number that we multiply by has to be between 1 and 10, we know where the decimal point goes. The decimal point has to go after the 2, 2.01. Okay, so we took our numbers in front of all the zeros and we put our decimal point right after the 2. Okay, now the question is, what power should we raise it to? We know it's going to be a positive power, but what should the power be? Well, our original number, 201 million, actually had a decimal point in it, believe it or not. We didn't write it, but the decimal point was right here at the end. We could have, if we wanted to be weirdos, we could have put some zeros after the decimal point there. We didn't because that would be weird, but we could have. There's a decimal right there at the end of that number. When we wrote it in scientific notation, we put the decimal after the 2. So the power that we're going to write is how many times did we move the decimal to get it from this spot right here where it was in the original number to this spot right here where it is in our scientific notation number? How many times, how many spots did we move that decimal? And the answer is 1, 2, 3, 4, 5, 6, 7, 8. We moved the decimal 8 times. And so it's going to be 2.01 times 10 to the 8th power. And that is this number, 201 million, in scientific notation, 2.01 times 10 to the 8th power. Okay, so let's look at our really teeny tiny number, our 51 millionths number. Again, we're going to be times 10 to a power. And this time, because it's a tiny number, tiny meaning less than 1, we know it's going to be to a negative exponent. So what's the negative exponent going to be? Well, we start off the same way that we did with the big number, which is that we look at the digits outside of the big long string of zeros. We get this big long string of zeros after the decimal point, and then after all those zeros are the digits 5 and 1. So we know it's going to be 51 times 10 to some power. Where do we put the decimal? Well, the number in front of the times 10 has to be between 1 and 10, so the decimal must go right here to make it 5.1. Now we ask ourselves the same question we asked on the big number. How many times did we move the decimal to get it from its original spot, which was right here, to the spot where we put it in our scientific notation number, which was right here? How many digits did we have to move that decimal over? So let's count. We moved it 1, 2, 3, 4, 5 times. Move the decimal point 5 times. And because this is a small number, a teeny tiny number, it's going to be to a negative 5th power. So 51 millionths in scientific notation is 5.1 times 10 to the negative 5th, and that's how you write numbers in scientific notation. The really big number is going to be a digit between 1 and 10 times 10 to a very large power, and a really small number is going to be a digit between 1 and 10 times 10 to a negative power.